Hi everyone, continuation to the fourth module. After disk scheduling, the topic is disk space management, which means we all know that in your desktop system you could see how the disk has been partitioned like C drive, D drive, E drive and F drive, and how files has been allocated inside it. That is what we are going to see. How the disk has been managed by partitioning, and what are the ways to partition a disk, and how the partition works, what is the benefit of it. That is what the content of disk space management. So disk space management is required for formatting in low level or for physical formatting. The main purpose is to format and dividing a disk into sectors, and that will be controlled by the disk controller to read and to write the data into the disk sectors, and each sector can hold the information like header and the data plus error correction code. So these are the three things which will be there inside in any of the sector. So first thing is header, which will be containing index and what the data which has been stored in that particular sector, along with ECC, error correction code. If any error is there in that particular sector, that will be handled by error correction code. So usually each sector will be able to store 512 bytes of data, but it depends based on that system OS. It will be varying sometimes. And to use a disk and to hold some of the files, OS will be having its own data structure, because any file can be stored in any of the sector, or data can be partitioned in any ways. If it is like that, then surely there won't be any efficiency in data storage and retrieval. That is why, to store the data and to hold the files inside the disk, each OS will be having its own data structure, which is like partitioning the disk into one or more groups of cylinders. So first of all, what are the number of disk it have? It should be partitioned, and each will be treated as a logical disk. And then comes logical formatting, which means making a file system, and to increase the efficiency of the file system, it will be grouped into the clusters. Like disk IO will be kept in one block, and file IOs will be kept in another block. Even you can take an example like in C drive, you could see that most of the software installation packages will be stored. So why? Because is to make the formatting more clear, that then only the retrieval at the storage process will be more efficient without any failures. If it is not organized properly, then it will take more time to store as well as to retrieve the data from any of the disk. So that is why it will be having its own data structure. And there will be boot block initializes boot block record, which will initialize the system, where all the data which is required for boot loading will be stored inside it. So bootstrap is stored in the ROM, and bootstrap loader program stored in boot blocks of boot partition. So whatever the OS program is there, that will be stored in read only memory. Why? Because it's for faster access. So whenever you switch on your system or mobile device, that gets loaded up very faster way. So all the data whichever belongs to bootloader, that will be stored in bootstrap inside the ROM. And even if any bad blocks are there, to handle that, OS will be having sector sparing. So if any block went wrong, then immediately sector sparing block will be initiated to recover that bad block. And this is how the booting from a disk in Windows 2000 happens. So for all the partition, the main thing is, first of all, it have master boot record. That is what MBR is, master boot record, which will be having boot code and partition table. Based on the partition table, the disk will be partitioned, and whenever any of the data enters, that will be added into the partition table, and from there boot partition happens, and it will be splitting into the number of partitions of the disk. So this is for Windows 2000. So for all the partitions, there will be a master boot record which will contain boot code and the partition table. And then comes swap space management. This we already know. Swapping, in the sense, it is like creating some virtual memory. Not all the data will be stored in the main memory. the data which are very much important and very frequently used, all those things only will be there in main memory. Rest of the things will be there in the hard disk. So whenever a data to be executed, that time even if the data is present in the disk, that will be pushed to the main memory, and from main memory processor will be taking into account for execution. Here the swap space is also the same. It will be like creating some virtual memory that uses the disk space as an extension of main memory. It is not exactly the main memory. So instead what it will create is, it will create some space in the space as a virtual memory in the disk itself, to make the processor to use that virtual memory for execution. So it is less common because of more memory capacity it is there in recent systems. In earlier system it is very common. Why? Because the capacity will be very low. So what happens is, it will be creating some virtual memory in disk space itself to make the processor assume it as a main memory. But nowadays we have increase in memory capacity in mobile devices as well as in the recent systems. So it will be storing the data in main memory itself. So swap space can be carved out of the normal file system, and it is can be separated. It is in the separate disk partition, which will be called as a RAW. And swap space management, let's see how it happens in different OS. First, let us see in Berkeley Software Distribution. BSD means Berkeley Software Distribution, which is a Unix based OS. 4.3 BSD allocates swap space when process starts. So whenever a process starts its execution, it allows for a swap space, which means to hold some of the text segment and the program and the data segment. So it won't be creating all the memory in the main memory. Instead it will be creating some swap space for storing the text as well as the data. And next comes kernel. Kernel uses swap map to track the swap space use, which means wherever the swap space have been created, kernel will be used to track where it has been created and what is the data it holds. Everything will be tracked with the help of the kernel. And Solaris 2 OS allocates swap space only when dirty pages is used out of physical memory, which means that if certain page fault happens, and if that page is not found in the physical memory, at that case it will create some swap space, so that the virtual memory will be created first and then the files will be loaded there. So after creating the virtual memory page, file data return to the swap space until it is requested by the processor, and other dirty pages go to the swap space, can also go to the swap space if it doesn't find any of the place in memory. And text segment pages thrown out once it has been read or once it has been written, or if they are no longer required, then it will be thrown out from that virtual memory. This is how the swap space management happens. Let's see in pictorial format. This is the data structure for swapping on Linux systems. So you could see that swap area has been there, which means that some virtual memory has been created in the disk to make the processor assume it as a physical memory, which means the main memory. So totally you could see some 5 blocks have been allocated. So whenever a page enters, like if it doesn't find space in main memory and if it enters into the swap area, that will be allocated here, like 1 in that first slot, and 0 in second slot, 3 in third slot, 0 in fourth slot, and 1 in fifth slot. So this is how the partition happens, and whenever the file enters into the swap area without any memory, then it will be allocated in the swap area. And if a processor requires this data, it will be fetching from the swap area and it will use it. And further, if the data is no longer required by any of the processor and if its work is over, then it will be removed from the swap area. So that is what about disk space management. So OS will be using disk space management for formatting, and it will be like how the partition should be done, what is the purpose of partitioning, and if we won't partition, what will happen, and all those things will be interfaced with the OS. Why? Because it's to make the data read and write to be more efficient. Thank you.